350 million years ago, long before the dinosaur era, planet Earth was a very different place. Endless tropical swamps teeming with towering ferns, intense humidity, and a high oxygen level in the air created ideal conditions for flourishing life, though not the kind we know today. The Carboniferous period was a strange, otherworldly era dominated by giant insects. Ever-present swampy tropical forests absorbed carbon dioxide through photosynthesis and released immense amounts of oxygen into the atmosphere. This raised the oxygen level to a record 35%. Such high oxygen levels became a powerful energy source for living organisms in this primeval jungle world. It was a perfect time for early vertebrates that were beginning to evolve but hadn't quite adapted to life on land, as well as various invertebrates that grew to astonishing sizes. It was a time of aggressive centipedes as long as a car, dragonflies soaring through the sky that resembled modern hawks, and giant spiders and scorpions the size of a bull terrier dominating the swampy jungles. The Carboniferous was an epoch when giant insects ruled the planet, transforming it into your worst nightmare. If you were to find yourself in the jungles of the Carboniferous period, the first sensation you'd feel would likely be lightheadedness, a sense of dizziness and dim vision. This would be due to the excessive oxygen levels, so abundant that even a small spark could ignite wet wood. Looking down, you'd likely see your feet sinking slightly into the swamp, which would be typical, since high humidity and swampy environments were a hallmark of the Carboniferous. But the real spectacle would be happening above you in the sky. If you lifted your gaze, you'd see something similar to birds flying overhead, their wings emitting a loud buzzing sound and a noticeable vibration in the air. These were giant, prehistoric butterflies, known as Paleodictyoptera. The wingspan of a typical representative of this species averaged 16 inches, with the largest specimens reaching up to 22 inches, nearly 10 times the size of modern flying insects. Paleodictyoptera were among the largest winged creatures of the Carboniferous. Their name, meaning ancient netted wing, refers to their intricate wing patterns, which resembled a delicate mesh. In addition to two standard pairs of wings with vibrant patterns, these insects also had small projections near their heads that may have acted as stabilizers during flight. On their heads they bore a proboscis used for consuming plant fluids, an early example of adaptation to this type of feeding style. Aside from their huge size, Paleodictyoptera had no way to intimidate you. They were harmless herbivores interested only in the nutrient-rich juices of plants. The same could not be said of a ground-dwelling predator of the Carboniferous, posing a deathly threat to anything in its path. You wouldn't have trouble spotting it, since it was the largest scorpion in the planet's history, known as Pulmonoscorpius curtinensis. It reached up to 28 inches in length. For reference, the largest modern scorpion, the emperor scorpion, barely grows to 8 inches. Pulmonoscorpius had a massive body covered with a chitinous exoskeleton, providing excellent protection from other predators. Its large, powerful pincers, equipped with sharp claws, allowed it to catch and hold prey. Meanwhile, its curved tail with a venomous stinger served as a death sentence for the prey, captured under the pressure of the pincers. Pulmonoscorpius was an active predator that, as a rule, hunted smaller arthropods, mollusks, amphibians, and reptiles, found both on land and in water. Its adaptation to the water environment made it thrive as a predator in ancient seas. And if you wouldn't have trouble noticing this giant scorpion the size of a bull terrier, it would also easily spot you. It had 2 pairs of eyes, 2 sets sensory for spatial perception, and another lateral pair likely for detecting light. Additionally, it may have had sensory receptors on its body, further enhancing its ability to navigate and locate prey. If you didn't consider yourself an arachnophobe before encountering this nearly 30-inch venomous scorpion, you might develop a newfound fear. But for now, let's return to the Carboniferous skies, where in addition to benign prehistoric butterflies like Paleodictyoptera, we encounter winged predators. This predator would look strikingly familiar as its descendants are around today. Dragonflies, except these were anomalously gigantic, over 10 times larger than their modern relatives. Meganora was one of the largest flying insects of all time. Looking at it, it's not that different from a regular dragonfly, albeit giant, and it kind of is, with a wingspan of 2.1 to 2.3 feet and a body length of up to 1.3 feet. They rivaled modern peregrine falcons in size. Over 300 million years ago, these giant insects were fearsome aerial hunters. They held the title of apex predator of the Carboniferous skies until the end of the Permian period, when the first gliding reptiles emerged, and truly their large compound eyes, providing nearly 360-degree vision, allowed them to spot prey from above and below. Additionally, their strong legs, with spines for capturing prey, were features of very aggressive and dangerous predators. It's believed that their prey often included the aforementioned giant butterflies. Their adaptability to different environments allowed Meganora to employ a dual hunting strategy. They could perch at the proverbial watchtower, waiting to ambush potential prey, or actively pursue it in flight. Fast and agile predators, they excelled at sharp aerial maneuvers, deftly avoiding obstacles while chasing their targets. While giant dragonflies did not have formidable opponents in the air, living on land presented challenges even for the mighty Pulmonoscorpius, especially when faced with another colossal creature known as Arthropleura, a titan among terrestrial invertebrates. Arthropleura could terrify anyone with its appearance and size. It's the largest millipede ever to exist, and simultaneously, the largest terrestrial invertebrates. In Earth's history, the smallest members of this genus reached up to 12 inches in length, while the largest specimens reached an astonishing 8.5 feet and weighed 110 pounds. Compare this to the longest living millipede today, Archosbaris trepkis gigas, which only grows to 13 inches. Their bodies consisted of 30 armored segments, each up to 1.6 feet wide, with a pair of legs. Under each segment, like many arthropods, Arthropleura periodically shed its exoskeleton. When it outgrew the protective outer shell, a new, stronger one would grow in its place. It's believed that Arthropleura had an extremely durable protective exoskeleton, which could shield its encounters with predators. However, it's worth noting that such confrontations with other animals were very rare, since the Carboniferous period wasn't known for having many predators. Even giant scorpions would likely hesitate to attack a millipede several times its size. No fossil fragments have been found of the head and mouth parts of these giants, so the diet of the larger specimens remains uncertain. Among the swamps, another predator lurked in anticipation of small reptiles and amphibians. It looked like an unusually large spider, although it wasn't a true spider. It was a distant relative, a sea scorpion known as megarachnid. Its incredible resemblance to spiders initially misled paleontologists when they first came across its fossilized remains, prompting them to presumably give it the name of megarachnid, which translates to big spider. However, after some time, it became clear that megarachnid was a sea scorpion of a noteworthy size. Its body length reached 1.8 feet, and its unique structure allowed megarachnid to feed using a method called sweep feeding. With paddle-like appendages, it would scrape through soft sediment in aquatic environments like swamps and rivers, capturing and consuming small invertebrates such as worms, insects, and smaller arthropods. Occasionally, it spoiled itself with terrestrial prey like reptiles and amphibians. However, the land animals were likely faster than megarachnid and were therefore less accessible prey. It appears that this sea scorpion would hide in a burrow or river, waiting for victims that came to close to its deadly lair. As for active hunting, its ancestor, Pterygotus, a giant sea scorpion that lived over 400 million years ago, feared much better. This species was not only more dynamic, but it was also larger than Megaracne. Its length was almost comparable to the height of an average human, 5.2 feet. And if you think this arthropod is unusually large, that's only an illusion. Compared to the giant, named Hippotopterus, Pterygotus takes a back seat. The length of the largest Hippotopterus specimens could reach 6 to 6.6 feet. They were likely record holders as the heaviest of their kind, due to their broad and compact bodies. This giant's feeding method was not that different from that of its smaller relatives. It was still the same sweep feeding method, except their diet may have included larger reptiles and amphibians. And no, this still isn't the limit for giant arthropods. The largest representative of this kind can confidently be considered Jeculopterus, which lived 400 million years ago. It reached a size of about 7.5 to 8.5 feet, making it one of the largest arthropods ever discovered. This giant's primary tools for defense and hunting were its claws. They could be approximately 1.4 feet long and were powerful enough to grab and easily crush their prey. However, such a large size did not equate to massive weight due to the simplicity of its anatomy, and despite having a length comparable to a car, the weight of a Jeculopterus likely did not exceed 220 pounds. Not all creatures of the cuniferous period were affected by the giant gene. Amid the humid prehistoric jungle were enormous dragonflies filled the skies, and the waters harbored giant scorpions. There were other beings, creatures so tiny you would struggle to spot them underfoot. Given the name Trigonotobita, these can be considered prototypes of the first spiders in history. The smallest members of the species were just a few millimeters long, while the largest grew to 2 inches. These were the earliest terrestrial arachnids known to science, having appeared over 400 million years ago. Long before the Carboniferous period, they were fully adapted to breathing air and no longer dependent on water. Their appearance was not too dissimilar to modern spiders. The body was divided into a cephalothorax and an abdomen segmented and covered in chitinous plates. Their legs were also similar to spiders. However, unlike modern spiders, they could not spin webs. Their cephalothorax was protected by a carapace, earning them the nickname armored spiders. These were some of the smallest predators of their time, hunting soft bodies in vertebrates like worms, for example. They likely didn't use venom for hunting and instead relied on grabbing their prey with their legs, holding it in place to consume it. It's possible that they also fed on plants, not unlike certain mites, that for reference had a similar appearance to Trigonotobita. The Carboniferous period was a playground for evolutionary experiments. Unique, gigantic, and often dangerous creatures dominated the air and land. Yet perhaps one of evolution's most fascinating experiments of this time period was conducted underwater, creating some of the most well-armored creatures of the era. Lepidocalius was an ancient worm species that lived around 400 million years ago on the territory of modern Australia. They thrived on shallow reefs and fed on organic waste. Measuring only a fraction of an inch in length, these creatures could only be observed in detail under a microscope. However, they have another more memorable nickname, the Excalibur worm. This name, inspired by the legendary sword of King Arthur, was earned for good reason. Externally, they resembled heavily armored knights, covered in overlapping plates of calcite, crystals that extended along their entire body. This armor provided extremely durable protection. Beneath the crystal layer was a light exoskeleton, similar to how knights wore chain mail beneath their armor. Additionally, the Excalibur worm could curl up into a ball, protecting its unarmored and, therefore, vulnerable body parts. The sharp edges of its crystalline armor made it even more formidable to potential enemies, as they would protrude outward when the worm curled up. Few creatures were capable of harming these armored worms. Biting through their crystalline shell was nearly impossible, and swallowing them was not a great option either. Evolution provided these worms with flawless defenses, but in the end this came at a significant cost. Even this solid protection that guaranteed safety from predators had a downside. The heavy armor limited their mobility, making it difficult to search for food or disperse to new habitats. As a result, the Excalibur worm left no noteworthy descendants. Their ultimate extinction coincided with the mass extinction at the end of the Devonian period. Amphibians began to diversify, and reptiles evolved into forms much like modern-day lizards, with a backbone, allowing them to live and move on land. These amphibians were also huge, and some species were predatory, resembling modern-day crocodiles armed with sharp teeth, and reaching lengths of almost 6 meters long. And like modern-day crocodiles and alligators, some evolved to have a thicker, scaly skin, which solved the problem of their bodies drying out if they were out of the water too long. And for the first time, amphibians evolved to lay amniotic or air-breathing eggs on land, and that changed everything, since these animals could now live out of and away from water sources. The Carboniferous period gave way to the Permian period that began approximately 300 million years ago, just 50 million years before the dinosaurs. All the continents during this period existed as one large landmass called Pangaea. The first large plant-eating and meat-eating animals evolved during this time. Some of these creatures could be mistaken for dinosaurs, but they were actually more closely related to mammals and reptiles. One of these bizarre creatures was Diplosarapsis. Looked a little like a salamander that averaged around 1 meter long, but its head was shaped like a boomerang. Another new reptile on the planet was the iconic Dimetrodon, which grew to about 5 meters long and had a large sail on its back, which is likely used to regulate its body temperature. During the Permian period, mammals were increasing in dominance. The biggest of these were creatures classified as Gorgonopsians, which were a class of giant, bear-like animals that all had different teeth that were specialized for different functions. These animals could be either herbivores or carnivores and vary in size from less than a kilogram to more than a ton. One group of these creatures were known as cynodons. Their name means dog-like teeth, and these animals had social behavior, and there is some fossil evidence that shows they hunted in packs. In the oceans, fish with true bony skeletons evolved. Sharks and rays flourished, as well as sponges and coral. On land, insects evolved with adapted mouth parts that allowed them to pierce and suck. But around 252 million years ago, the Permian era came to an abrupt end by a cataclysmic event that caused mass extinction. In 2001, scientists made a chilling discovery. A massive comet or asteroid, similar to the one that put an end to the dinosaurs, wiped out the giant reptile predecessors 200 million years earlier. But how did scientists come to this conclusion? Molecules of helium and argon gas were found, locked in carbon in high proportions, that could have only come from space. It is estimated that the asteroid or comet was between 6 and 12 kilometers wide in diameter. Researchers say the strike would have released the energy 1 million times greater than the biggest earthquake of the last century. Aside from this discovery, there is some evidence that current-day Siberia and China experience volcanic eruptions on an unimaginably massive scale, and those eruptions created dust and ash clouds that blocked out sunlight. Not only that, but over 1 million years, 3 million cubic kilometers of lava poured out of the ground, covering the entire planet in a layer 10 meters thick. The asteroid impact, combined with volcanic activity, was the proverbial blast from a double-barreled shotgun. The Earth was once again a very unhappy place. The The combination of these two events resulted in what is called the Great Dying. 90% of all marine animals and 70% of all land animals that were alive during this time perished. The extinction event of the Permian-Triassic era 252 million years ago marked the beginning of the Mesozoic era of the Triassic, Jurassic, and Cretaceous period, which lasted 186 million years. During the Triassic era, there was one vast supercontinent called Pangaea, which was mostly vast deserts with a hot and dry climate, surrounded by a huge ocean called Panthalassa. Dinosaurs would begin to evolve during the mid to late Triassic period. When we talk about dinosaurs, we immediately imagine towering and thundering animals like Tyrannosaurus rex. But new research shows that the dinosaurs and their pterosaur relatives evolved from extremely small ancestors. Proof of this theory was discovered in Madagascar, when a newly discovered reptile species was found, named Congonophonculi, or tiny bug slayer. It lived some 237 million years ago and stood just 10 centimeters tall. It's one of the first small animals found from the root of the Ornithodora family tree, and is an important discovery. The miniaturization event in which it lived served as a survival strategy for early Ornithodora appearance, and whereon its teeth showed the tiny creature preyed on insects. This eliminated the need for them to compete with their relatives for meat. Furthermore, researchers of this tiny dinosaur relative showed that feathers and other fuzzy skin coverings found on the later true dinosaurs and pterosaurs likely originated to protect the tiny dino ancestors from the extreme climate of the mid to late Triassic period when the first dinosaurs evolved. The Triassic marked the rise of the reptiles, mainly the archosaurs or ruling lizards and therapsids or mammal-like reptiles. For reasons unknown, the archosaurs had an evolutionary edge, muscling out their mammal-like cousins and evolving by the mid to late Triassic into the first true dinosaurs, such as Eoraptor and Herosaurus. Dinosaurs were divided into two main branches, Saurischian, which means lizard-hipped, and Ornithischian or bird-hipped dinosaurs. Eoraptor was at the root of the Saurischian family tree. It was only 91 centimeters long and weighed about 11 kilograms. It had long legs that allowed it to run fast, and its front paws had sharp claws that helped it to grab prey. Herosaurus was more advanced in evolution than the Eoraptor because it had a joint in its lower jaw. It had a large skull, and its jaws were armed with the sharp teeth of a carnivore. It averaged in length from 3 to 6 meters and had 5 fingers on each paw with blunt claws. Storchosaurus was another early true dinosaur that was about 2 meters long with a large skull, as long as its femur, and there were 13 to 14 sharp teeth in its upper and lower jaws. It had short front paws with 5 fingers. It had long hind legs that allowed it to run fast. Storchosaurus was a predator that weighed about 30 kilograms, and although this dinosaur was kind of small, it probably had no trouble dealing with larger prey. Eoraptor, Herosaurus, and Storchosaurus are prime examples of the rapid evolution of predatory dinosaurs 225 million years ago. But at the same time, the first plant-eating dinosaurs appeared in the fossil record. Pisanosaurus was a 1-meter dinosaur that weighed 2 to 9 kilograms and had closely spaced teeth, forming a continuous edge for grinding plant matter. By the late Triassic period, there were at least 15 different dinosaurs. During the Jurassic period, Earth's climate changed from hot and dry to a much more humid and subtropical climate. Forests of ferns, cycads, and conifers began to cover the planet, and the air was warm, moist with tropical breezes. During the beginning of this period, the breakup of the supercontinent Pangaea continued and accelerated. Laurasia, the northern half of the continent, broke up into North America, and Eurasia, the southern half, called Gondwana, began to break up during the mid-Jurassic. The eastern parts, Antarctica, Madagascar, India, and Australia, split off from the western half of Africa and South America New oceans flooded the spaces in between. Huge mountains rose on the seafloor and pushed sea levels higher onto the continents. It was all this water that created the humid and subtropical climate. Deserts began to turn green. Palm tree-like cycads and conifer trees, such as the araucaria and pine, were abundant. The oceans became full of diverse and abundant life, and at the top of the ocean food chain were the marine reptiles, the plesiosaurs with their long necks and paddle fin flippers. Among them were giant marine crocodiles, sharks and rays, ichthyosaurs, squid-like, cephalopods, coil-shelled ammonites, sponges, snails, and mollusks were abundant in the ancient oceans. Coral reefs grew and expanded quickly in the warm waters, and microscopic plankton increased rapidly to the point that they may have turned parts of the ocean red. The earliest known bird, Archaeopteryx, took to the skies in the late Jurassic, likely evolved from an early coelosaurian dinosaur. Archaeopteryx had to compete for airspace with pterosaurs, flying reptiles that had been buzzing the skies since the late Triassic. Meanwhile, insects such as leafhoppers and beetles were abundant, as many of Earth's earliest mammals scurried around the feet of dinosaurs. It was at this time that the dinosaurs began making their mark in a huge way. Literally, small, quadrupedal, plant-eating dinosaurs gradually evolved into multi-ton giants. The plant-eating sauropod named Brachiosaurus was 16 meters tall and stretched out to around 26 meters long and could weigh as much as 25 tons. Another herbivorous sauropod, giant named Diplodocus, was 27 meters long and weighed between 30 to 50 tons. The sheer size of these dinosaur giants may have stopped the attacks of a bulky meat-eating dinosaur that walked on two powerful legs, who also lived during this time, the ominous Allosaurus. This huge carnivore ranged in size from 7 to 12 meters long, weighed nearly 2 tons, and had 16 sharp teeth in its upper and lower jaw. And like many predatory dinosaurs of the Mesozoic era, Allosaurus constantly grew, shed, and replaced its 3 to 4 inch teeth. And this dinosaur was fast. Models suggest that Allosaurus could run up to 34 kilometers per hour. Fossil evidence shows that Allosaurus preyed on Stegosaurus, and the plant-eating dinosaur fought back, punching holes right through Allosaurus bones with its spiky, club tail. It could be why Stegosaurus had a pretty long run and survived all the way up to the late Cretaceous. But there were new predators that would come along that were as equally terrifying as the Allosaurus. The North American Tyrannosaurus rex could grow 12.5 meters long and weighed up to 8 to 10 tons, although now some say it might have weighed half of these estimates. But the T-Rex wasn't alone in the meat-eating dinosaur category. In fact, it was either outclassed or equal to two other sharp-toothed monsters, the South American Gigantosauros, which had the same type of build and weighed 9 tons, and the 10-ton Northern African Spinosaurus. Still, the T-Rex was a mean and nasty predator, if not downright unhygienic. Experts believe that shards of rotten bacteria-laden meat was constantly lodged in its closely packed teeth, which gave the animal a septic bite that would eventually be fatal to its wounded prey. Of course, this process would have taken at least several days or weeks, and another T-Rex would probably reap the rewards. Scientists examining the T-Rex skull determined it had the bite force of between 1,500 to 5,000 pounds per square inch and could take bites of flesh in the 225 kilogram range. But Tyrannosaurus rex, like Allosaurus, had problems with prey itself. It lived in the same region and time period as some armored plant-eating dinosaurs. One of the most iconic dinosaurs next to T-Rex has to be Triceratops, which means three-horned face. Triceratops had 3 horned skulls. 2 massive horns were above the eye socket, and 1 smaller horn was over the nose, weighing around 6.5 to 13 tons. The biggest Triceratops was 9 meters long from nose to tail. 3 meters off the ground. Triceratops had teeth arranged in dental batteries, and each individual tooth was stacked in a vertical column of 3 to 5 teeth. These formed rows with 36 to 40 tooth, loaded columns. This means that a single Triceratops could have 800 teeth at its disposal. It had a narrow beak and powerful jaws that allowed it to grind down tough vegetation and trees. It is one of the last non-avian dinosaurs to evolve at the end of the Cretaceous. Ankylosaurus is another of the most famous armored dinosaurs. It was the largest ankylosaur and the last of its kind. It is thought to have lived right up to the end of the Cretaceous period. The body of Ankylosaurus was covered in bony plates. It had a beak and teeth and 4 horns that projected backwards from its head. Its tail ended in a club, which provided protection from predators. This would have been useful since Ankylosaurus lived alongside Tyrannosaurus rex and other meat-eating predators. At some point during the middle of the Cretaceous period, dinosaurs from the ornithopod family evolved into the popular hadrosaur or duck-billed dinosaurs. They were large, oddly shaped, low-slung vegetation eaters with tough beaks on their snouts, which were used for shredding vegetation. These dinosaurs are believed to have lived in herds and were capable of walking on 2 legs. Sauropods became even bigger by the late Cretaceous period. You may have thought that Brachiosaurus and Diplodocus were big, but by the time the late Cretaceous period rolled around, there was another dinosaur that existed, which could possibly be the biggest land animal that ever walked the earth, Argentinosaurus. This behemoth could be 30 to 40 meters in length and weighed between 50 and 100 tons. It was a member of the Titanosauria, the dominant group during the Cretaceous period, and was a herbivore like its earlier sauropod cousins. There was also a strange new breed of dinosaur that lived 20 million years before they all went extinct. They were called Pachycephalosaurus, or bone-headed dinosaurs, and have a bizarre-looking skull with horns on the snout and around the base of the skull. These could have been used to fight off the last of the big predators, or even to show dominance over their own species. Of course, there were more than 700 different dinosaurs that have been found so far, but not enough time to cover them all in one video. There are some dinosaurs that lived in the colder regions when they were further south and within the Antarctic Circle during the Cretaceous. During this time, there could have been some snow and ice, and temperatures as low as -10 degrees Celsius during the 3-month long dark winters. There were a variety of different dinosaurs living in this polar zone. In 2014, a skull section and upper and lower jawbones were found in the miniature T-Rex called Nanoxaurus hoaglandi. It's believed that many dinosaurs had feathers to protect them from the elements, and this tiny T-Rex cousin was about 6 meters long. It's now believed that all species of Tyrannosaurus rex had feathers to protect them from the elements, and Nanoxaurus was no different. Other dinosaurs like the horned and duck-billed dinosaurs, along with other small feathery predators, parrot-like oviraptors, and a small herbivore named Leelinosaura lived in the polar region as well. But their time would soon come to an end. Everyone talks about how dramatically the dinosaurs went extinct, but judging by the whopping 165 million years they survived, they might just be the most successful vertebrate animals to ever exist on planet Earth. In fact, some dinosaur relatives are still around on the planet today. Modern-day birds are, in fact, descendants of feathered dinosaurs, and you might be surprised to learn that crocodiles are the closest living relatives to birds, as they shared a common ancestor. The two groups are the only known survivors of the archosaurs. We all know what happened to the dinosaurs, and if you missed our video on the day the dinosaurs went extinct, we'll put a link in the description for you. Please let us know in the comments what you thought about the video, and tell us what you'd like to see next. Stay tuned for more cool videos, and thanks for watching.